So I do want to make a third video here just on this section of graphing parabolas and also knowing different details about parabolas, like finding the vertex, finding the axis of symmetry. These are all questions that come out on the test. So I'm lumping all these questions up as a certain type of topic, which is graphing parabolas. So let's do a couple of these. So this is a parabola. Obviously, we're going to graph it. You could look at it in standard form, or you could look at it in vertex form. Let's look at it in standard form.
What number is that?
I don't know the exact number, but you could find it on your practice test. But my point is, if you look at it in standard form, there is no bx term. There is no term in the middle. So because there's no term in the middle, when you find your vertex, which is a coordinate, and you have to use a formula, x equals negative b over 2 times a, and when you use that formula, use parentheses, negative b over 2 times a, and the b value, as you can see, is 0. So whenever your b value is not there, you're going to end up plugging in a 0 there, and it doesn't even matter what number's on the bottom, because 0 divided by anything is still 0. So your vertex x value is 0, and when you plug in the 0, you're going to end up with the c value as your output, 3. So it's really easy to find the vertex when there is no b value, even if it's in standard form. All right? So let's graph that vertex at 0, 1, 2, 3, which is right here. And we obviously know that there's an axis of symmetry right through it. We need more coordinates. We could use a pattern 1, 1, 2, 4, 3, 9 if your a value is 1 or negative 1, right? Now, this is an a value of negative 2, which means that we need to modify this pattern. And how do I do that? I simply take that a value of negative 2 and multiply it. Now, the negative, I already know that it's just going to cause the parabola to open down instead of up. So I'm actually just going to multiply times 2 times 2 times 2. And again, that's only because the a value is 2. If the a value were 3, I'd be multiplying everything by 3. Not everything, the outputs. All right, the outputs. This 1, this 4, this 9, you multiply it by whatever your a value is. Again, I'm not even including the negative because the negative just means that it opens down. So instead of 1, 1, I'll get 1, 2. Instead of 2, 4, I'll get 2, 8. Instead of 3, 9, I'll get 3, 18. So I'm not using the 1, the 4, the 9. It's really the 2, 8, and 18 that it becomes modified to. So from the vertex, I know that it's opening down. I'm going to go 1 over 2 down. So 1 to the side and 2 down, and let's put a dot right there. And we go back to the vertex and we do 2, 8. So 2 over 1, 2, 3, 4, 5, 6, 7, 8 right there. And all we have to do is mirror it to the other side of the axis of symmetry. And what do I mean by mirror? This is 1 unit away, so go 1 unit this way. This is 2 units away, so go 2 units this way. And we just graph our parabola, and we're done. Easy peasy. This one right here, I've already explained it in detail on the other video, on your practice test. What I want to do is go through it quickly here. Again, we're going to find the vertex, and the vertex, we use a formula. And when we use that formula, we're going to use parentheses so we don't make any mistakes. The a value is 1, the b value is 5, and the c value is negative 1. So you're going to plug in a 5 right there and a 1 right there. So for the x value, you end up with negative 5 over 2, which is negative 2.5. And how do you find the y value? Once you already have your x value, you plug it in, right? So we're going to rewrite the equation, but with parentheses instead of the x's. And of course, we're going to plug in the x value of negative 2.5 in there. And again, I say use the calculator. Use the calculator. Type it in exactly the way you see it. Parenthesis, negative 2.5, close parenthesis to the second power plus exactly the way you see it. And the calculator should do all that hard work for you, and you'll get y equals negative 7.25. Okay? Again, if I'm going too fast, watch the other video. It's more explained in detail. So my vertex is negative 2.5 and also a negative 7.25. And so that's my vertex. So let me go to that vertex negative 2.5. So from the origin, negative 1, negative 2, and then halfway to 3. And then go down negative 7.25. So 1, 2, 3, 4, 5, 6, 7. 0.25 is a quarter of the way down. So you put a dot right there. It's kind of floating in between the actual nice coordinates because of the fractions or because of the decimals. Now we know that the vertex is here, and we know that there's an axis of symmetry through it. We also know that this opens up or down. It opens up. Now, when you look at your 4 multiple choice answers, you're going to be able to eliminate the ones that open down. And there's going to be 2 of them left. And out of those 2, you might have one that crosses the y-axis right here at negative 4, and you'll have another one that crosses the y-axis maybe at negative 1. What I'm trying to get at here is you're going to be able to look at both of those graphs, and they both open up and they both have the same vertex, but you need to know which one's which. So you want to find the one that has the right y-intercept. So the key on this one is to find the y-intercept. So to find the y-intercept, to find out where your parabola crosses the y-axis, you simply set x equal to 0 and solve. Now because there's 2 x's, you put a 0 in both of them, and what's your final answer going to be if you plug in 0 right here? Plug in 0 on both of these, what's your final answer going to be? It's going to be negative 1, right? So, I mean, look at that. We came up with that answer without even writing down any work. It's just we know that the y-intercept is at negative 1. So knowing that, guys, you'll have the right answer. You know your vertex, you know it opens up, and you know it crosses the y-axis where? Right here at negative 1. There will be no other parabola that crosses the y-axis at negative 1. Okay, I'm just letting you know. I've already seen the test. I've seen the multiple choice answers. So all you need to do is find the vertex, know if it opens up or down, and then after that, find your y-intercept, and you'll be able to identify which one's the correct one. Just for a quick sketch, I would just map this over. So again, this is a sketch. Now, why am I saying use the y-intercept? Well, when you calculate the y-intercept, it'll tell you where it crosses the y-axis, right? Now, if you didn't have a multiple choice test, then I would recommend for you to do the pattern 1, 1, 2, 4, 3, 9. And you still could do it, but I mean, it'll take longer. And especially if the graphs are already there, all you got to do is find that y-intercept, and you'll be able to see which of those 2 parabolas that are left that are opening up, which one actually crosses at the y-intercept at negative 1. But like, let's say this wasn't on the final, let's say it was just actual graphing. Well, you would have to go from this point 1 over and 1 up, right? So you're at this halfway point, and you go 1 over to this halfway point, and then you go 1 up. So from this quarter point, you go up to this quarter point, and this would be the actual coordinate of your detailed graph. Does that make sense? Right there? And then, let me zoom out a little. Then you would go back to your vertex, and the pattern is 1, 1. We already did that, 1, 1. Let's go 2, 4. So 1, 2 units, and I'm at the halfway points, and then 4 up. So you're at 1 at the quarter point, 2 at the quarter point, 3 at the quarter point, 4 at the quarter point. So that would be your dot, the next one. So this sketch that I did, it's pretty close to the actual graph itself. You just had to make it more right through those coordinates. But for the sake of the final exam, knowing that y-intercept gives you the answer. Okay? Not all of them are going to be on graphing, but it is questions related to graphing, like find the coordinate of the vertex. This is a standard form equation. You can't convert it easily to vertex form, so you have to use the formula. So x equals negative b over 2 times a, and I guess we get another fraction here, but that's okay, let's do it. Let's use the formula correctly with parentheses instead of the b and the a. Let's identify a is 1, b is negative 3, c is 2, which we're not even using. The b value is negative 3, a value is 1. So my x of my vertex, remember the vertex is really a coordinate, the x value is really positive 3 over 2, which is a 1.5. Yay? So the x value is 1.5. We still need the y value. In order to calculate the y value, you simply have to plug in the x value that you have. So let's rewrite the entire equation. y equals, but instead of x's, let's put parentheses, x squared minus 3x plus 2, and we're going to plug in that value of 1.5. Now, when we do this, again, you could use a calculator. And if you do it correctly on the calculator, you should get negative 0.25. So your y value is negative 0.25. Negative 0.25. So maybe your vertex on the multiple choice is not given to you as decimals. They might write it as the fraction 3/2, comma, 0.25 is 1/4, and it is negative. So they might give it to you that way. Now the Casios are nice because you could convert them from fractions to decimals with that SD button. Anyhow, calculators help you out a lot, especially when your vertex x value is a fraction. So we've graphed standard form equations. We found the vertex. Graphing vertex form equations, there's definitely a couple of those on the final. Let's do some of those. Like on this one, it's super easy to find the vertex on a vertex form equation. The vertex is your h and k value right there and there, but when you identify h, think opposite. So the vertex is -3, and the k value, you take it exactly the way it is, -5. So if you do go -1, 2, 3, -5, you'll end up at that coordinate right there. Let's plot that point, -3, -5. We draw an axis of symmetry right through it. Does this open up or down? Up. Okay. Now, you know it opens up. We need a pattern. The a value is not 1, so you can't use 1, 1, 2, 4, 3, 9, but you do have to modify the second numbers on this pattern by the new a value of 2 times 2 times 2 times 2. So instead of 1, 1, you have 1, 2. Instead of 2, 4, you have 2, 8. Instead of 3, 9, you have 3, 18. So from the vertex, we're not going to go 1, 1. We're going to go 1, 2. From the vertex, we're going to go 2, 8, not 2, 4. From the vertex, 3, 18. Actually, that's going to be off the graph, so we're not going to do that. So let's go back to the vertex and go 1 over 2 up, and we end up right there. Let's go back to the vertex and go 2 over 8 up. So 2 this way, and 1, 2, 3, 4, 5, 6, 7, 8 right there. And 318 is going to be off the graph, so I'm not even going to do that. Then I'm going to map them over to the other side, right there and right there. And we have our nice looking parabola. So vertex form is even easier. I love vertex form. So there's a couple more left on the final on graphing. As you can see, we have this standard form one. To find the vertex, you go -b over 2 times a, draw the axis of symmetry, and you can use the pattern 1, 1, 2, 4, 3, 9 opening down because the a value is negative. We've already done an example of that, so I'm not going to do that one. Or should I? You guys want me to do that one?
Number 9.
Sorry about that. Not explaining every single one, but I did let you know that there's about 8 questions of these types, right? And combined with graphing. So that's a huge chunk of the test as well.